This time on Captain Cash's Laboratory, we're going to be working on Shelly's diner, but not the diner, the sign. But I wanted you to see the diner. Look at this thing. Yeah, it's a beautiful piece. Old 50s style. It's a bulb-lit piece. Bulb goes there. But it has an in and an out for the sign. Power in, power out to the sign. And you can turn the sign on or off. On or off. So, I wanted you all to see the diner, in case you've never seen it before, because I never have. And this is very nice. This is a very nice piece, a very nostalgic piece of the old 50s diners. I was a big fan of like the Five and Diner when I was around. Out here, they're all pretty much gone because the 50 diners were pretty cool. So I'll set this aside, out of the way, so it doesn't get broken. So here's the sign. The problem with the sign, it doesn't turn on. And when I hook it up to my power supply, I don't have an adapter. I'm sure I do. I've been packing stuff for relocating this bench. At 3 volts, this thing is pulling almost 1 amp and none of the lights are coming on. That is bad. So that's the center hot. I just put a bar in to make contact for my center connector. Like so. And then this outer is the ground, which is putting a hell of a strain on my power supply. It drops it from 3 volts to 2.7 and it pulls 0.85 amps, and then if you let it sit, the voltage drops, the amperage goes up, so there's something shorted in here. And I don't want to keep sending power to it because something will eventually smoke. Probably one of these LEDs is bad. I've worked on a few of these, not this, but a few of these older pieces that use the older style LEDs, and when they go bad, they create a dead short. So I'm going to assume that's the problem. So I'm going to make some room. Looking at the back of the sign, we have a divot and a divot. Give us access to the inside. So it uses LEDs and Christmas lights. No, Christmas style lights. 4 of them. I'm looking at the little bulbs to see if I can see anything blown. All the filaments look okay. Well, we're going to check this out some more here in just a moment. Pardon me for a second. I have apparently somebody's come up to the door. I will be back in just a moment. Alright, we're back. Sorry for the interruption. FedEx delivery. Alright. Let's try and figure out what in here is going bad. I'm hoping it's not the LEDs, but it most likely is. I want to check these lights with actual power. So we're going to pop them out and we're just going to hook them right up to the machine, because these are incandescents. When incandescents go bad, they just don't work. They don't really short out. So the filaments all look relatively good. Oh, maybe that one's popped. It's hard to see. the cable is just hot glued in the bottom. It's so old that the glue is actually peeling off pretty easy. I want to see if there's a splitter in the bottom, because there's 2 sets of wires that come out of the top and only 1 set of wires go in the bottom. There we go. So there's got to be a splitter inside this arm area or stand. The reason I say that is, one, see how thick the wire is, see how thin the wires are, and also 1 set of 2 sets of 2. It actually looks like this base may separate right in here. And I guess we're going to have to start testing these lights and find out where the problem lies. I wish I knew what the voltage was. It doesn't tell you on the box. Department 56 is really good at not telling you. It just tells you it comes with the bulb, and that's all. Let's see what's this size, just in a different language. So on a multimeter, this symbol right there means diode. These are diodes. LED is light emitting diode. I'm gonna just start checking them and see if I can find the bad one, I guess. It's gonna be interesting. Might have a hard time because they're all on their track. And they're all... No, I should still read them, actually. No, that might be part of the problem. Supposed to give me the forward voltage of what it takes to turn on the light, but it's telling me there's no continuity on this diode. This is a brand new... There we go. I had it for a second. I think my lead is bad on my meter. It got crushed in my drawer and it got damaged, and I think it's I think the connection broke internally. So we'll pull out Old Faithful. I've had this meter for like 20 years. So yeah, this one's working fine. The LED is lighting up. It's a dim light. It's not like it's ultra bright, but it tells me it's 1.8 volts basically. So this is how you test LEDs. We're going to start here on this side and see which is positive and which is negative. So that one's good. 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 The number is very little because of the color and the tolerance between that one's good. 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 Tree, you're in my way. So the inner track is negative and the outer track is positive. Good. Good. So if I reverse them, I shouldn't get a reading. Yeah. So I'm just going to go back over them in reverse polarity because a diode is like a one-way door. It means power can only go in one direction. That's why if you put an LED in backwards, they don't light up. So if a diode is failing, I will get reverse connection. So if it's not any of these and it's not the incandescence, which we'll check next, then it might be where the wires come up the center. Maybe there's a short, or there's a resistor in there that has failed and is getting really hot. All right, so none of them are bleeding backwards. Move that out of the way. There's 2, 3, 4. All right. So we're going to try this at a lower voltage because I don't know what the voltage is. So it could be anywhere from 3 volts up to 12. I don't know how big the resistor is, so we're going to start at 3. Being incandescent, it doesn't matter which way we connect the wire. It should just start to glow. Can't get this one to connect. Good. So there's no light, so it could be because the resistance is too high. So I'm going to bump it up a little. Nothing. So, yeah, filament looks connected using the magnifiers, but it's so thin. We'll do a resistance check across the filament. It's bouncing, but it's between 5 and 8 meg ohms. That is a lot of resistance. So let's take a check at the next one here. And that one's the same. And the next one. This one's shorted. That's what the beep was. This one's in K ohms. Let's try this one again. This one was coming up as shorted. Shorted would cause the power supply to show that high amperage draw. Oh, I think it's just the meter must have slipped. Excuse me. All right. So the one that's detecting shorted. Let's see what the meter says. So that's 1.8 volts. Wasn't shorted. I think my meter slipped. That's 3 volts. That's pretty bright for 3 volts. And that's 4.5 volts. So this is probably a 3 volt setup. Meaning 3 volts goes into this. So I probably still have a bad LED or a bad connection in the base. Let's check them all. There are 3 volts. Volts. They're pulling 1/8 of an amp. So far all 3 have. Oh, same with that one. There's 3 volts to all of those. Alright. So with the incandescents out, now we're just dealing with the LEDs. I'm only getting the reds and the yellows. I think that LED, or excuse me, that light that was shorted was probably the problem. It was probably the connection was bent. That's why when I touched it, it went off. Well, now I'm bumping up the power to 4. We're at 4.5. And now all the lights are working. Hope you can see that. I'm letting it play for a minute through its flash mode so you can actually see that all the lights are flashing in groups of 3. So you got 3 here, 3 here. These 6 come on. 3 here, 3 here, 3 here, 3 here. So at 4.5 volts, it's pulling 200 milliamps. So one of these guys that had the mangled base somehow created a short. Process of elimination. That's all I'm doing. See, can I get this to stay on? Yeah, like that. So I can test them with 1 bulb at a time. There's 1 bulb. There's 2 bulbs. No light. So that might be a bad socket. Let's try the other light just to be safe. Oh, that one works. Alright, let's check these wires. Everything's lit up. It's at 4.5 volts. It's pulling, holy smokes, 810 milliamps. Because those are incandescents. If those are LEDs, they would draw a lot less power. So you would need to have a 1 amp feed at 4.5 volts to power this sign off of that house. 8, actually it just spiked up to 860, 860, 870, 7800 or 780, 770. So it's fluctuating. So it's peaking at 870 milliamps, which is well, it's just under an amp. So whatever's feeding this sign has to put out some decent juice. And the biggest thing is this. When these 4 were plugged in, because they're incandescent, it jumped up a lot. Because these 4 right here pull a 0.5 amp by themselves. So if you can replace these with LED versions, which they do have, they're just hard to find, you would lower the power consumption of this sign and its temperature, because these guys are getting warm because they're incandescent. Actually, they're starting to burn my finger, so I'm going to turn it off so I can put them back in that backer and not have my flesh get stuck to them. Those Christmas necklaces with lights on them, and especially at this time of year, you can find replacement low voltage Christmas light bulbs, like at Ace Hardware as an example. You can sometimes find them in LED, and you just got to convert them. If the bases don't fit, then just pull the bulb out of the base and swap the base. I'm sure anybody that's been doing Christmas lights at any point in their life that's had to replace a bulb from a different manufacturer's string knows how to pull the bulb out of the base. But that's what I would recommend as far as changing these, because the only time I can find replacement low voltage Christmas light style bulbs is at, well, Christmas, even though these bulbs are used in other things besides Christmas lights, and they're just hard to find. So let's put the sign together and make sure she still works like she's supposed to. Let's wrap that wire around like it was, and I have it upside down. Of course I do. So this was a relatively simple, just diagnose it, checked all the LEDs, they all work. You could have just plugged it in, but I wanted to make sure they're all within tolerance. And then the problem was one of those incandescent bulbs, the wire had shifted and became a short. And that's probably due to the fact that it's heat and cold, expansion, contraction, or when it was assembled with a slight issue, and it just took time for the wire to move. So I'm going to go kill the light so you can see what this thing looks like. So that's the big light, overhead light, and bench light. Look at that beautiful sign, which is all screwed up because of the balance of the camera. So we'll tip it like that. So there is the Shelly sign. I'm going to fire up the hot glue gun. Let's do that now. And so I can glue this track back in, just in case I had to peel the wire out to get to the resistor inside. The reason I know there's a resistor is the LEDs, the red and the yellow and the green, they all run around 2.2 volts. It's at 4.6 right now. It's 4.5, 4.6. It's bouncing back and forth. So they would all burn out due to being overpowered. Whereas these incandescent bulbs are probably 6 volt rated. That's the standard in the miniature holiday lights that are battery operated. They can handle up to 6 volts. And they're just really bright. On the old school Lemax lights where they had the light in the stem that you stuck in the bottom of the house, I have a video showing you how to fix those. And that's what I did, is I bought a pack of those Christmas lights that are made for batteries and soldered them back on. I also show you how to do it with an LED. I would recommend sticking with the incandescent because it uses the incandescent bulb as a balance for the motor. And when you put LED in there, the motor gets loud because it's no longer load balanced. It spins faster, creates more noise. In this case, there's a splitter so that the incandescents run at full power and the LEDs run at a reduced voltage using a resistor. So, you know, light's coming back. So this is a pretty cool little piece with the lit building. She doesn't have the adapter that feeds the power into the side. She just gave me a bulb, which doesn't do any good. As far as the sign goes, it is very easy to open, as you saw, but we're going to do a quick recap while the hot glue gun gets hot. Get that off, pull that out, like so. So you got a tab and a tab, pop the cover off. That's how you change your light bulbs, and you can inspect everything. If you think your wire is damaged inside the actual sign post, peel the glue off. You can peel the rest of that out too. You'll have to pull it all out. So, and then you can probably pull the wires up through or pull them back down. Now, if you can't refeed them, there's a seam right here and there's a seam right there where you could probably heat this up and wiggle this out, because I can actually flex it by just doing that right there, where there's probably a dab of glue, and it might make it easier because inside here, which this looks like it doesn't come apart. No, this looks like one piece of extruded plastic, would be a resistor for the LEDs, so you don't burn them out. But this is the Department 56 Shelly Diners sign repair, and it wasn't too horrible. Mainly because it really wasn't a big repair. It was just finding out where the short was, whether it was in the wiring, whether it was in the LEDs, or whether it was in the incandescents. And I didn't think it'd be the incandescents because that's pretty rare. The LEDs are more common, and I was wrong. And I tested all the LEDs, forward and backwards. You saw it on the meter. They're really easy to test. And found out that it was an incandescent where one of the wires had folded over and made contact. So should have just checked the incandescents like I thought. But if you watch this whole video, then at least you got a little education on how you can test your LEDs with a multimeter if you need to. Generally you don't have to. LEDs, the newer ones, when they go out, they just don't work. The older ones create a short in the whole the whole system fails. I know I just repaired a couple of pieces from Department 56 that is old, and the LEDs failed and created the rest of the piece to not work. These older style LEDs, when they go bad, if they short out, they will over amp. Basically, they let all the power go through to least path of resistance, and you get no other lights. It's not common, but I've come across it now with the 2 pieces I did yesterday, I don't know, probably 6 times in the last 5 years on these little miniature houses. So it does happen. You need to be aware of it. And with this video, if you watch it or watch through that part, hopefully you'll get an understanding how to check it. LEDs only work one direction. If you do them in the wrong direction, they don't. You should get open or OL. Matter of fact, while that glue cures so I can scrape the excess off, it might be dark enough that you can see the glow on this LED. So we'll go back to diode, turn that back on. Oops. I didn't press it in the first time. So hopefully you'll be able to see it. Come on, would you? I can't see it either. It's too dark. There we go. And you can see it's 1.845 volts to turn this LED on. So when I was touching each one of these LEDs on the sign, if the sign would have been facing the other way, each one of these would have glowed, just like that one did. And if I test it backwards, it doesn't glow, and it just says OL for overload, or some people call it open line. The point is there's no connection. It doesn't go through. It's a one-way door. So, but hopefully that helps educate you a little bit on LEDs. They're very simplistic. If you overpower them, they don't work anymore. If you underpower them, they're really dim. And if you have a short in an LED, old style, they will take out all the other lights until you fix the one that's bad. And the new style, just that LED doesn't light up anymore. It's because they changed the material that they're made with on the inside. Well, the ones were made with like gallium and a few other components, and the new ones aren't. And that's why the new ones are also more brilliant. They're brighter, more true in the color spectrum. So, but anyhow, that sums up this video. Thanks for watching. Till the next repair, have a good one. Okay, little addendum. I didn't realize that the diner lit up as well with the power. So here's the sign, and here's the diner. The word diner lights up, not the light bulb lights everything up. With these additional LEDs in with it, it runs at 6 volts. At 4.5 volts, the sign barely turns on and the diner's dim. And it's pulling 1.4 amps. So you need to have a 6 volt, 1.5 amp or stronger power supply, because it spikes at 1.41. It runs right around 1.3. And that's because, again, the flashing of the sign. But yeah, this thing, that's why I wish they put the voltages on the box. But they don't. You would need a 6 volt for that smaller port on the side. 1.5 amp minimum power supply to make the sign work at full function, where you get all 3 colors, and to get the word diner to work on here as well. So I did not know that the word diner lit up. Again, I've never seen this before until today. It's right there. So this is the in, which is smaller. This is the sign, or the out, which is fatter, you can see. And we got the on-off switch. You can turn the sign on. Like if they're closed, the interior lights would be off, but the sign might still be on. And this is just the Limax cord reversed. This is the part that plugs into the bottom of your Limax. And that's how I tested it to make sure we're all good. So that was just a quick addendum that on this piece, you should have a 6 volt additional power port. Again, this thing didn't come with the correct cord, so I don't know if she has it and lost it, or had it and lost it, or has it and give it to me. But for those who have this piece, 120 volt light, which goes on the bottom, which I already showed you, but just in case you missed it, it goes right there. Then you got the big track coming out the back, which I'm assuming it had a splitter wire on it. Could be wrong. And it plugged in over here. Or it came with 2 power cords, which I'm more apt to believe based on the shape of the foam of the box. Because the diner fits right here. The sign fits right here. So diner goes there. Light bulb goes here. That could be a 6 volt power supply that's missing. I don't know. Again, I don't have this piece. If you have this piece and I'm correct, or if I'm wrong, comment below. If anybody else that has this piece is trying to fix it or get the voltages, so they know, because it'd be important, because nobody labels their stuff anymore. And Department 56 isn't standard. Lemax went to 4.5 volts across the board. They got rid of their 3, 6, 9, and 12 volt systems. Department 56 still runs from 2.7 volts all the way up to 120, and they go from AC and DC. So, and they always say, just use this adapter, 56 dot something, something, something. Voltages be great, because sometimes they even discontinue their original adapters, and then you can just go buy a generic. But you want to make sure you have the right power consumption, or power rated for its consumption. So, but anyhow, here's a little addendum, because I wanted to make sure everything worked, and I want to make sure that pass-through worked before I send it back to the customer. Because if the pass-through doesn't work, that means I got to open the side of that piece and replace that switch, because that's the pass-through. 2 wires go in, one goes all the way across, then the switch breaks the other one. Yeah, so anyhow, again, thanks for watching. Till the next repair, have a good one.